Can a place as vast and mysterious as the ocean ever be the safest refuge on Earth? For millions of years, the seas were home to strange and dangerous creatures, a realm where humans were only beginning to take their first steps. But there was a moment in history so brutal and chaotic that the roles were reversed. Water, once a symbol of danger, became the only possible refuge. It was a time when land offered no safety. Every inch of it was covered in death, poisonous gases, fire, and ash. The cause? One of the most devastating volcanic catastrophes ever recorded in the planet's geological history. What you're about to uncover is not just a historical event. It's a powerful reminder of how Earth itself can turn against its inhabitants. This is the story of the only time when diving into the ocean was safer than staying on land. Imagine a world without humans, a planet where the dinosaurs had already disappeared, and the mammals were just beginning to claim their place as the new dominants of the Earth. We were located approximately 252 million years at the end of Permian. Just before the period started Triassic, it was an era of transition, of construction and destruction. During the late Permian, all continents were united into a single supercontinent, Pangaea. This vast landmass was gigantic, so large that its interior suffered from climatic extremes. The central regions were dry and hot, almost desert-like, while the coasts closer to the seas could have more temperate conditions. But it was not a stable world. The atmosphere then was loaded with carbon dioxide, much more than today. Global temperatures were high, and the poles barely supported ice. The oceans, although vast, were suffering from chemical alterations that threatened marine life, such as dead zones and low oxygen levels. Despite these challenges, the biodiversity was amazing. On land, huge non-dinosaur reptiles, such as Dicynodontes and the Gorgonopsids, dominated the ecosystems. In the seas, creatures like ammonites, brachiopods, and trilobites. They thrived alongside various forms of fish and primitive corals. However, something lurked beneath the surface. Deep within the planet, a pressure was slowly building, and what was about to happen would change the course of life on Earth forever. The beginning of this transformation began in a region today known as Siberia. There, a crack opened in the Earth's crust and released one of the largest volcanic eruptions in the history of the planet, Siberian Traps. This event was not a simple explosion. It was not an eruption like the ones we usually imagine. What happened was a colossal release of basaltic lava, which extended during hundreds of thousands of years. Lava flowed for miles, forming entire plateaus of molten rock. But that wasn't the worst. With each eruption, tons of carbon dioxide, CO2, and sulfur dioxide, SO2, were released into the atmosphere. Sulfur dioxide caused acid rain, destroying entire forests and contaminating the soil. Carbon dioxide, for its part, trapped the sun's heat, brutally accelerating global warming. The oceans began to warm. In doing so, they released methane trapped in the seabed, a greenhouse gas much more potent than CO2. This phenomenon further amplified warming, plunging the planet into a catastrophic domino effect. The mainland became hell. Extreme temperatures, toxic rain, massive wildfires, and skies reddened by ash and smoke were the norm. Breathing clean air was impossible. Plants died, soils became sterile, and food chains collapsed. The impact was such that it began what we know today as the Great Dying, the largest mass extinction in the history of the planet. It is estimated that the 96% of marine species and around the 70% of terrestrial species, they disappeared. Nothing and no one was completely safe. And yet, in the midst of that apocalyptic chaos, there was a refuge, a chance to survive. Water. In the depths of the ocean, away from intense solar radiation, extreme heat, and atmospheric pollutants, some life forms found relative stability. Microorganisms, primitive fish, and certain species of invertebrates managed to resist adverse conditions, hiding in areas where oxygen had not yet been completely exhausted. It was not a paradise. The oceans were also slowly dying, but compared to land, ravaged by fire, gases, and ecological collapse, the deep seabed became a sanctuary. For the first and only time in the history of life on Earth, the sea was the only place where continuing to breathe was still possible. It was the beginning of the end for thousands of species, and the dark prelude to a new beginning. Before the disaster, Earth was a vibrant ecosystem. In the dry forests and plains of Pangaea, dicynodonts, robust herbivores with a bulky body and turtle-like beak, grazed in herds. With short, strong legs, they were slow but efficient, adapted to eating hard, scarce plants. Their success had made them one of the most diverse groups in the Permian. Next to them walked the fearsome gorgonopsids, the main predators of the period, with enormous fangs resembling those of a saber-toothed tiger. These cold-blooded carnivores could reach impressive sizes, effectively hunting any prey that came their way. His gaze, probably penetrating and fixed, was a constant threat on the solid ground. In the skies there were no birds yet, but giant insects such as wide-winged dragonflies and armored beetles buzzed among the ferns and primitive conifers. On the ground, small tetrapods, distant ancestors of today's reptiles and mammals, crawled among the dry leaves and fallen logs. At sea, the story was different. The oceans were a vast laboratory of evolution, teeming with strange life forms. Ammonites and nautiloids. They sailed with their spiral shells while the crinoids, distant relatives of starfish, swayed gently anchored to the seabed like underwater flowers. Primitive bony fish and cartilaginous sharks dominated the food chain. There were corals, although very different from those we know today. They were simple structures without vibrant colors, made up of resistant organisms that grew slowly. Sponges, trilobites, although already in decline, and a rich variety of mollusks and brachiopods completed the mosaic of marine life. But when the Great Eruption began, death did not discriminate. The first to feel the impact were the inhabitants of the Earth's surface. A permanent darkness covered the sky, similar to a nuclear winter. Plants, deprived of sunlight, began to die en masse. Without vegetation, the dicynodonts collapsed, and without them, the gorgonopsids became extinct shortly after in a cruel chain of disappearances. In this scenario, competition and brutality were not enough to survive. The fiercest were not necessarily the fittest. Speed or strength could not protect anyone from poisonous air or acid rain. Many of the land animals died from suffocation, poisoning, or simply starvation. In the ocean, the tragedy was slower but just as inevitable. The extreme heat and the release of gases caused a sea acidification, affecting creatures with shells, such as ammonites, which depended on calcium carbonate to build their structures. As the water became more acidic, their shells dissolved, leaving them vulnerable. Oxygen in the water also began to become scarce. Large areas of the ocean became anoxic zones, authentic underwater deserts. Many species simply suffocated in their own habitat. Most of the reefs disappeared. Trilobites, which had existed for hundreds of millions of years, were finally wiped out. However, not everything was extinction. Some small organisms found ways to resist. Certain mollusks, adapted to low oxygen environments, managed to survive by taking refuge in deep crevices or migrating to colder, nutrient-rich areas. Extremophilic microbes thrived in conditions that were lethal to others, slowly initiating the process of biological reconstruction. And, in a twist of Darwinian irony, the simplest creatures, those who did not dominate or hunt, were not majestic or large, were the ones who managed to survive best. On land, the only ones that resisted were small animals, with slow metabolisms and nocturnal or underground habits. These survivors, including some therapeutic primitives, the ancestors of mammals, dug and hid underground, protected from the toxicity of the surface. Meanwhile, underwater, the deepest depths became a sanctuary. They were not comfortable or abundant places, but there, far from the volcanic gases, the scorching light and the atmospheric pollution, life could continue. Barely. This moment marked a before and after. Life as we knew had been devastated, and only the most humble, the most adaptable managed to keep the flame burning. It was the reconstruction of the world from the rubble, and although the worst was not over yet, the seeds of the future were beginning to germinate. underwater. When everything around you dies, it's not about being strong or fast, it's about resisting. The planet was broken, a landscape devastated by scorching heat, toxic rains, endless fires, and acidic oceans. But even in the midst of collapse, some living beings discovered how to cling to existence. How did they achieve it? With strategies that would seem at first glance insignificant, but that saved entire lineages. Let's start under the sea. In a world where oxygen was becoming extinct, many species simply could not survive. But some organisms were already prepared for extreme environments. The anaerobic bacteria, which did not need oxygen to live, thrived in these dead oceans. They were microscopic, invisible, but essential. These bacteria became the new architects of life, capable of processing toxic chemical compounds and transforming uninhabitable habitats into small oases. Some primitive fish, they also adapted. Some developed slow metabolisms, moving as little as possible to conserve energy and oxygen. Others sought refuge in deeper waters, where the acidity was lower and the temperature more stable. Those who could migrate did so. Those who didn't disappeared. Among the mollusks, only a few species managed to resist. Those with thinner shells or the ability to retract completely into the sediment survived the corrosive environment. Their descendants would evolve millions of years later into more complex forms, marking the beginning of a new branch of marine life. One of the most surprising adaptations was the formation of resistance capsules. Some microorganisms and small forms of marine life managed to enclose themselves within hard or gelatinous structures during the most adverse conditions, entering a kind of hibernation. When the environment stabilized, they woke up and continued their life cycle. On land, the panorama was even more cruel. The large reptiles almost completely perished. But the small therapsids, reptiles with mammalian characteristics, had an unexpected evolutionary advantage. The burrow, living underground, protected them from unbearable heat, toxic smoke, and acid rain. These animals, similar in size to a weasel or a badger, fed on insects or roots, and their low metabolism allowed them to endure long periods without food. Additionally, they probably had a primitive form of internal temperature control, something that modern mammals would later perfect. Another advantage was the reproduction with hard shell eggs, or even the viviparismo, give birth to live young. This ensured that the offspring did not have to develop exposed to the lethal elements of the surface. As for the plants, the most resistant were those capable of generating long-lasting spores or entering states of dormancy for years. Some types of mosses and ferns managed to stay alive in small pockets of underground moisture or in rock crevices, protected from extreme heat. A key factor in survival was ecological flexibility. Organisms that did not depend on a single food or a single habitat were the most likely. This trait, known as ecological generalism, it was vital. While specialized species, adapted to very specific niches, disappeared en masse, generalists managed to adapt to new conditions, even if they were extreme. And even more important, the small size. Smaller animals required fewer resources, could hide more easily, and tolerated sudden changes better. Extinction favored the tiny, the discreet, the resilient. In short, life became humble. What was once a world of titans and towering hunters became a haven for tiny, resilient, silent creatures. This transformation reminds us of something deeply human, that in the worst moments, it is not the one who shouts the loudest or the one who dominates with violence that survives, but rather the one who knows how to adapt intelligently, the one who hides when necessary, the one who resists in silence until the storm passes. And that's exactly what happened. The species that would dominate the world millions of years later, including our own ancestors, were not the giants of the Permian. They were small, almost invisible animals, hidden underground or floating in the deep currents of the sea. History would give them another chance. The world was ready to start again, from its foundations. Imagine a world that breathes fire. A world where the sky turns black for years and then red, and then there is no sky. Just ash. This is what the Earth was like during the Great Permian Dying. But to understand why it happened, You have to go to the heart of the disaster, to the Earth itself, which opened and began to vomit death. It all started with a series of volcanic super-eruptions in a region we know today as Siberia. But this was not a simple chain of volcanoes. It was something incomparable. For almost 1 million years, the Earth's crust continuously released lava, covering more than 7 million square kilometers, an area the size of Australia, in what is now called the Traps Siberianos. The consequences were immediate and cumulative. These eruptions released colossal amounts of carbon dioxide, CO2, and methane, CH4, to the atmosphere. CO2 intensified the greenhouse effect, and methane, even more powerful, sent global temperatures skyrocketing. In just a few tens of thousands of years, a breeze in geological terms, the Earth became a pressure cooker. Global temperatures increased by up to 10 degrees Celsius, a brutal change. The seasons were no longer predictable. Extreme droughts devastated the continents, while unprecedented heat boiled the oceans. But that was just the beginning. Volcanoes not only emitted greenhouse gases, they also released huge amounts of sulfur dioxide, SO2, which reacted with water vapor to form acid rain. These precipitations destroyed forests, poisoned lakes, and altered the pH of soils. Plant life began to collapse, and with it, entire ecosystems. Additionally, the thermal devastation caused massive wildfires. Deposits of burned carbon have been found around the world, evidence of an Earth that burned relentlessly. Smoke and soot rose into the atmosphere, blocking sunlight and causing temporary cooling, followed by even more severe warming as the smoke cleared and the CO2 persisted. At sea, the disaster took another form. The increase in temperature reduced the water's ability to retain oxygen. This caused the formation of enormous anoxic zones, oxygen-depleted areas where life simply could not exist. But in addition, the high temperatures caused the release of methane clathrates frozen on the ocean floor, further amplifying global warming. And if that were not enough, the combination of volcanic gases and decaying organic matter poisoned the atmosphere. The result was a drastic reduction of the ozone layer. Ultraviolet rays reached the surface without a filter, burning skin, mutating DNA, destroying tissues. The sunlight became lethal. The poles, once cold and stable, melted. Ocean circulation patterns changed completely, altering the salinity and temperature of water on a planetary level. And so the ocean stopped being a place of life and became a deadly trap, saturated with ammonia, acidic and without oxygen. On land, desertification was relentless. Fertile regions became dry wastelands. The mountains were burning, the jungles were becoming extinct, the soil became infertile, and without vegetation to protect it, the planet began to erode from its roots. And the most terrifying thing is that this catastrophe, it wasn't instantaneous. Unlike an asteroid impact, this apocalypse lasted hundreds of thousands of years. A slow but unstoppable extermination. Every decade, every century, new species disappeared. Some held out for a while, but eventually fell. Global biodiversity fell to minimum levels. 96% of marine species, 70% of terrestrial species, insects, reptiles, fish, amphibians, plants. The catalogue of life was torn page by page until it was almost empty. And then the Earth fell silent, the silence of a wounded planet on pause waiting for its reconstruction. But even in the midst of this climate hell, some forms of life, as we saw before, managed to persist. Not because they were stronger, but because they found ways to adapt to a collapsing world. However, this recovery would not be quick. The planet would need millions of years to rise again, the seas to recover their oxygen, the atmosphere to clean its poison, and life to reinvent itself from its simplest forms. The worst chapter in the history of the planet had just been written. But the next one would begin with a whisper, and that whisper came from the water. It is difficult to imagine what it means to lose almost all life on the planet. But that's what happened in the Permian-Triassic mass extinction. It was not simply a decline. It was a global collapse, a prolonged suffocation, And although we have already seen the natural horrors that unleashed this catastrophe, we need to understand how life was extinguished, how the balance that had held for hundreds of millions of years was broken. The sea fell first. The oceans, once the cradle of impressive diversity, became uninhabitable. Water temperatures rose beyond the tolerance threshold for almost all complex marine organisms. Reefs of sponges, primitive corals, and bryozoans completely collapsed. The dead zones, lacking oxygen, expanded from the depths to coastal areas. Even plankton, the basis of the entire marine food chain, mostly disappeared. Without phytoplankton, there was no new oxygen. Without zooplankton, there was no food for fish or invertebrates. The collapse was total. Even trilobites, which had survived for more than 270 million years, including previous extinctions, were gone forever. Ammonites, brachiopods, and armored fish fell like dominoes. Some tried to migrate, others survived a few more centuries in distant corners. But destiny was written. What was once a complex network of marine life became a barren plain, a liquid tomb. On land, the story was no different. The forests disappeared, literally. There are geological records that show a gap of Poland, an almost total absence of spores and fossilized seeds in sediments from that time. Trees, giant ferns, and seed plants perished. The plains were left empty. Rivers dried up or became acidic. Herbivorous animals left without food died en masse, and with them the carnivores. Entire ecosystems collapsed like houses of cards. The gorgonopsids, dominant predators of the Permian, were among the first to disappear. These reptiles with fierce appearance, tiger-like fangs, and powerful bodies were victims of their specialization. They were hunters of prey that no longer existed. Without their sustenance, they quickly fell into extinction. The Dicynodontes, robust herbivores, some the size of a rhinoceros, also did not survive. Even smaller, more adaptable groups saw their numbers plummet. Of all the large terrestrial vertebrates of the Permian, less than 10% survived the event. The same thing happened with insects. Although many people do not consider them, insects form the invisible backbone of terrestrial ecosystems. During this extinction, insect species declined dramatically, the only event in Earth's history in which this has occurred on such a scale. The causes were multiple, but they fed each other like a death spiral. Unbearable heat, lack of oxygen, infertile soils, air pollution, acid rain, disappearance of habitats, loss of food, and the increase in diseases and genetic mutations caused by ultraviolet radiation. And yet, although all seemed lost, not all life was erased. Small groups managed to survive, some burrowing therapsids, semi-aquatic amphibians, certain primitive fish, heat-resistant bivalves, and microorganisms. Scientists still debate exactly why some species managed to cross this extinction threshold. But there are factors in common: small body sizes, slow metabolism, ability to enter states of torpor, rapid reproduction, and above all, enormous ecological flexibility. Species that could feed from various sources, endure abrupt habitat changes, and take refuge in extreme niches. And here something curious happens. Even though the entire planet was collapsing, water in certain places became safer than land. At the bottom of the ocean, where temperatures were more stable, some microecosystems managed to persist. Hydrothermal vents, for example, harbored chemosynthetic bacteria that did not depend on sunlight. These colonies became bubbles of life as the surface burned. In sea caves or deep lagoons far from the coast, some species found refuge from heat and pollutants. The land, exposed and vulnerable, was more dangerous. There was no shade, there was no vegetation. The sun was burning. The winds carried toxic dust. It was an open oven. For the first time in the planet's history, water, normally more unstable, offered respite. Not everywhere, but yes, in some key places, and that small margin made the difference. The Permian-Triassic extinction lasted between 60,000 and 100,000 years in its most critical phase. Some studies extend it to 300,000. The recovery time was much slower. The Earth took more than 10 million years in recovering minimum levels of biodiversity, but he did it, And it was thanks to those few who survived, those who found a burrow, underground, a puddle protected from the heat, an oceanic crevice where they could breathe. These survivors would mark the beginning of a new era, the Triassic, and with it, the evolution of the first dinosaurs, and later, of us. The Earth has already faced the end of the world and survived, but not without scars. The Permian-Triassic extinction reminds us that even the seemingly invincible, like a planet full of life, can crumble through a chain of imbalances. Today, volcanoes do not roar as they once did, but human carbon dioxide emissions surpass those of the Permian in speed. We are altering the chemistry of the oceans, warming the atmosphere, eroding forests, displacing species. Have we learned something? At that time, water saved lives. Today, we can save it. The planet does not need us to rescue it. Life will return, eventually. The question is, will we be there to see it? History has already shown us what happens when we cross certain limits. Maybe this time, we can write a different ending.